Welcome to the Discover Mathematics series. In this video, we're going to look at how students can use algebra tiles to discover the rules for the addition and subtraction of polynomials. In a set of algebra tiles, there's actually 6 different tiles. This set has them labeled, three pieces are labeled with a plus sign and 3 pieces are labeled with a minus sign. The minus ones are red, and the plus ones are positive. You can ask the students why the minus is red, and they can give you a variety of reasons why they think the minus tiles are red. But when we look at the tiles, we're going to call this first one here a 1, or a unit. And the length is 1, the width is 1, so the area is 1. So we're going to call it 1 because its area is 1. The second tile right here, the width is 1 and the length we're going to refer to as x. So when we do that, the width is 1 and this length is x. This is 1 and this is 1. So here the area is x. 1 times x is x. And this next tile, the area, the length is x and the width is x. So we're going to call this, it's x times x, and the area is x squared. So we're going to refer to these tiles by their area. Now these on this side are the same dimensions, except we're going to call them the negative. So this one is going to be -1. This one is negative x, or negative 1x, and this is negative x squared. Okay, here we're going to ask the students to use algebra tiles. They're going to build the model, and then they're going to sketch, because this will serve as their notes. So we see in question number 1, it says x squared. So here's our x squared plus 2x plus 1. And that's what they have. So that you can easily see if the students have built it correctly, even if you're using algebra tiles that are not labeled. Okay, so we want them also, it says build and then sketch. So they can sketch it on the side here or below. You don't need to use colored pens, but we're going to have, here's our x squared, and then we have, these are little rectangles, and then a small x. Okay, so if they're just using the same color pen, we could say that the positives are going to be clear and the negatives, when we encounter them, could be shaded. Okay, let's look at the next question. We have x minus 4. So when we have x and we want to show minus 4, so instead of, so we have 4, but we can't take 4 away from x. So here are the 4. But what we're going to do, because we want to be able to combine terms later on when we're working with the polynomials, we're going to need to, because you cannot change the order when you're subtracting, then we're kind of hindered. We're limited in what we can do. So instead of x minus 4, what we're going to do is change this to x plus -4. So we're going to add the opposite. Instead of subtracting, now, because it says -4, we're going to flip the signs. So we're adding the opposite. And that way, it's going to allow us to change the order. Because we cannot change the order when we're subtracting. Like 5 minus 2 is not the same as 2 minus 5. So we're limited. This way, when we add the opposite, then we'll be able to move items around, move the tiles around, and It makes it much more powerful. So when we go to sketch this, we're going to just sketch an X, and then our 4, and then I'm going to shade them in, and I notice that I changed it over here on the problem as well. It's X plus a -4, and that's what I've illustrated. So they can go through and just build different things. What they're going to see is there's nothing we can do with them. We just built them. So now let's look at what happens when we go to add polynomials. Okay, let's look at our first problem here. We have x squared plus 2x plus 1 plus another term. So I'm going to build the x squared. It's my x squared plus 2x, 2 of the x's, plus 1. And then I'm going to add that to 2x squared plus x. I'm going to put it above so you can, I can put it here, so you can see it, plus 3. Okay, so right here we have our first polynomial plus our second polynomial. When we go to add them, so we built it, and then when we go to add, what we're going to do is just put them together, and we put together the things that go together. So we'll end up with 3 of the x squared, the squares that are x by x, 3 of the x terms, and 4 of the units. So this gives us, for an answer, 3x squared plus 3x plus 4. And what's interesting is when students are actually using the tiles, very rarely will they say something like the 2x plus 1 gives them something x squared, because it doesn't make sense. They can see it, and that's what's powerful about the algebra tiles, is they're going to put together what goes together. Okay, let's look at the next question. Of x minus 4, you might remember from just a moment ago. So instead of building an x minus 4, I'm going to build an x plus -4. So this gives me x plus -4 x plus -4 is the first term, and then I have an x squared plus x plus 4. And we've built each one separately. Now when we go to combine them, what we're going to notice is that these two give us 2 of the, nothing goes with the x squared, we get 2x, and then when we go to put these together, you can think of it as a 0 pair. If you have, so a +1 and a -1 makes a 0 pair. It's like if you have $1 and then you give the dollar away, then you end up with nothing. You can also see the 0 pairs when you look at the adding or subtracting integers, which is on a separate video. So this gives us a 0 pair. We'll move it aside. This gives us a 0 pair. We'll move that aside. This gives us a 0 pair, and this gives us a 0 pair. So what we're left with is x squared plus 2x. If they were actually going to sketch it out and so it would serve as their notes, then I would just have them circle the zero pair so they see that they go together. And they can do a few more examples where they're going to practice, but what we want them to notice when we get to the question, what do you notice? Because they're going to ask you, well, how long do we have to use the algebra tiles? The question is, until you can tell me how to add polynomials without using the algebra tiles. Because what we want them to notice is that you can only combine the ones that are the same. Like you can combine an x squared with an x squared term. You can combine x's with x's, but not with anything else. And then you're going to use the same rules that we have for integers when it comes to combining. If they're positive, they add together. If they're a positive and a negative, you're going to end up subtracting them because you have a zero pair. So next, let's look at this example here where we have x squared plus 2x plus 1 minus the quantity 2x squared plus x plus 3. So I built both terms, but what I'm going to do here is instead of, because with subtraction we can't move anything around, is I'm going to change it from subtraction to add the opposite. So I'm going to add, and you might think of it as a -1, and then I'm going to distribute, so I'm going to add the opposite of everything in the parentheses. So what that does on my algebra tiles is now I'm going to have negative x squared, and this is a negative x squared, and this is a negative x, and then these are negative. So I'm just adding the opposite of everything. I'm just flipping them over. With the tiles, I'm flipping them over. The operation is I'm adding the opposite. And now I can just combine like terms. So I see that I have an x, a positive x squared, and a negative x squared. That gives me a zero pair, and I'm going to move those aside. And then I have a negative x and a positive x. That gives me a zero pair. And then I have a -1 and a +1. That gives me a zero pair. And I'm left with these, so it makes sense to put the largest one first. So I'm going to have a negative x squared plus x minus 2. And that's going to give me my final answer. So this gives me, when I add these together, or subtract actually, it gives me minus x squared, or negative x squared, plus x plus a -2. I like to write the plus the -2 because instead of subtracting, it's just easier to work with addition. So we're adding the opposite. It also allows us to use the commutative property so we can change the order. So that's going to be my answer. Let's look at another question. Let's look at question number 3. When we have 3x squared plus 2 minus x squared plus (3x plus 1). So I built both, but now before I move anything around, I'm going to change this to add the opposite. If you want to think of it as a -1, that's fine, but we're just going to change the signs for everything, the opposite of everything. So with a little flip of the wrist here, we're going to change this to negative x squared, negative 3x, and a -1. Okay, now we just combine our like terms. Well, we see what happens. We can put a negative x and an x together. That gives us a 0 pair. We have this -1, and oh, there's nothing that goes with that. And then we have a +1 and a -1. Gives us a 0 pair, and this is, so those are 0 pairs right there. And then this is what we're left with. We have x squared, 2x squared, plus -3x plus 1. So what we should see is that it's exactly the same. Subtracting is exactly the same as addition, except we add the opposite of the whatever's being subtracted, the second term, and that means with our algebra tiles we're just going to flip them over. Or using the symbols, we're just going to change them all to the opposite. We're just going to go through and change them to the opposite first. Then, once we do that, we just have regular addition. So we don't have, other than switching the signs or flipping the algebra tiles over, we don't have any new process for subtraction. And that's what we should notice, and we add the like things together. And that finishes this video. Thank you.